The first thing to understand about Balatro's RNG system is the use of hashing. Hashing is where we pass in a number or string into a hash function, and it scrambles it without using randomness. Meaning if we pass in bold, it might scramble it to this weird looking 30-digit number, but it will always scramble it to this 30-digit number. So first of all, when a fresh run starts in Balatro, we need a seed. If the player gave one, then we use it. If they didn't, we use the time on the player's system clock and their mouse position to create an 8-digit string. Technically not random, for all intents and purposes it might as well be. And if we are playing the tutorial, the seed is set to tutorial. For an example, let's say we start a run with the seed bold. We then create an empty table called pseudo-random. Table in Lua is like a dictionary in Python. It has keys and values and works kind of like a textbook. We can look at the contents page, which shows us all the keys in the table, and we can then flip to a page for that key and read all the values written there. As well as holding onto our seed and this blank table, we also hash our seed and save this hash seed for later. Now later in the game, when a random value is needed, a call is made passing in a key which denotes what this random number is for, like idle or wheel. For this example, let's say we've used the wheel and we have called for a random number with the wheel key. On this key, we perform 3 steps. First, we check if the pseudo-random table has a wheel page. If it doesn't, then we make one by sticking together our seed and key, bold wheel, and then hashing this we get a scrambled number which we use as the initial value for the wheel page. Second, we take the current value on the wheel page of our pseudo-random table and we perform a different hash on it. This hash can be considered to be a sort of increment. Since the function produces the same output for the same input, you can keep passing a value into this function, getting another one out, and then passing that one back in. The numbers produced will look wildly different and random. This is actually a sequence of numbers, which is always the same if it has the same starting points. We then write the next value we get from this sequence to the wheel page, replacing the old one. And the final step is to take a copy of the value on the wheel page, half it, and add on our hashed seed that we saved at the start of the run. This step can be understood a bit like this. If the previous step gives us a sequence, then the jumps between each value are technically constant. By mixing in hashed seed, we make it so that the jumps between the values in the sequence are of random length. It's still the same length each time, but it now depends on the seed at the start of the run, which ensures a more random output at the end. The function outputs this value, which is then set as the math seed, and the operation to get the random number or string is performed normally.